Before we can start creating our first semi-serious code sketches in Vex, we need to talk about an extremely powerful concept and tool when writing Vex code. We need to talk about functions. Functions are sometimes also called subroutines or procedures. And what they are is a bunch of code that's been neatly packed away for us to use to do more complex things than, say, just summing up two values. For example, creating a point. You can think of functions as commands that you can call in Vex. For example, this is a function call that would create a point. Let's have a look at it in detail. So telling Vex to execute a given function is called calling a function, or a function call. And the function call usually requires these parameters. On the one hand, the function name, in our case, add point, and then in parentheses, the parameters or arguments for that given function. In our case, we have two arguments, an integer number and a vector. The first number, the integer, would tell the function on which geometry stream it should create the point, and the second number, the vector with the three components, would tell the function at which position it should create a point. So in this case, our function would create a point at the center of our scene, 0, 0, 0, on the geostream coming in through slot 0. That's the first port in our wrangle. However, some functions can also be used to generate a value. And addPoint is kind of a special case here, because it can be used to either generate what's called a return value, which we can then use in our code, or it can be called in such a way that it only generates a point and does not return any value. So in this case, we call addPoint and tell it to store its return value in a variable called newPt. And addPoint will return the newly created point's number, which we'll then store in our variable called newPt. After this line of code, we did two things. On the one hand, we created a new point at the center of our scene, and on the other hand, we stored this point's point number in our variable newPt. So if a function gives back a certain value, that is called a return value, in our case, the point number. Sometimes functions will return different data types, depending on the variable type that is used to store the return value. So for example, this function here, rand and then some number, will generate a pseudo-random number in the range of 0 to 1, and in this case, return a simple float number, having a value between 0 and 1. However, there's more to it. So let's have a look at Houdini's single most useful help page. So when we're in Houdini, let's go to help and to the contents. In here, let's search for Vex Functions. And the first hit we have here, Vex Functions, is a really central, really important help page when it comes to writing Vex and learning Vex. Because listed here, you will find all Vex functions that exist in Houdini. And on the one hand, what you can do by just hitting Ctrl F, you can search through this page. So I can search for random, and I have like 16 hits, but that is a bit clumsy. So what I can do, if I have any idea about my function name that I search, I can filter this page. So let's just put in rand here, and I can see I get all my functions containing the string rand. And I was looking for this function here. So let's get in there and learn to read this function documentation. This style of documenting your functions and your language might seem a bit weird when you're not used to it. However, it is pretty standard when you look at different programming languages. So we have to get used to reading these kind of documentations. So let's step through it. Here we have the function name, rand. And it's a Vex function. We already knew that. Now we have a short description of what this function does. So it generates a random number between 0 and 1. We already knew that. From a seed. Next in this block, we see a summary of all the possible ways that we can call this function. So up here, this is our bread and butter way of calling this function. We would like to use the function rand to generate a float value. And in order for that, it needs a float argument. So the seed we feed it, like 1, 2, 3, 4, usually is a float number. Next, we can also call this rand function using a float number as a seed to generate a vector with two components. We can call it the same way to generate a vector with 3 components and a vector with 4 components. This block here tells us that we can call the rand function also using 2 seeds, both floats, again to generate a float number, a vector with 2 components, 3 components, and 4 components. The next block tells us we can also call rand with a vector containing 2 components, again to generate all these data types. We can call rand with a vector containing 3 components, and we can call rand with a vector containing 4 components as a seed. So these are just all the possibilities how you can call the rand function, specifying which data types the function needs as an argument and which data type it will return as a return value. Next, we find a bit more detailed description of what the function does. Rand creates a random number based on the provided seed. Okay, what does that mean? The usual way you generate random numbers is with some mathematical algorithm that takes an input value, which is called the seed, and then it somehow jumbles this input seed to provide an output value, which seems kind of random. However, if you call this function rand with the same seed, it will generate exactly the same output value. So it will calculate a pseudo-random number based on the input seed that you feed it with. You can maybe think about this as having a perfectly precise robot that is rolling dice. And you can think about the seed maybe as the throw angle of the robot which is rolling the dice. And if no parameters change, a perfect robot will always roll the dice resulting in the same numbers. Only if you change the robot's parameters will it throw the dice differently and thus get out different numbers for each roll. So let's go on here. The number will be in the range of 0 to 1. We already went over this. And the same number is produced for the same seed. That's what I've been talking about with the robot example. So to vary the random number, the seed should be varied. Makes sense. Different seed, different return value. Note that even the smallest change in the seed value will produce completely different numbers. So it may produce different results on different operating systems or compilers. Okay, this tells us two things. On the one hand, the difference in our seed number can be really small to generate totally different output numbers. So a seed of 1 will produce a totally different output number than a seed of 1.001. Also, the second part of the sentence, so it may produce different results on different operating systems or compilers, tells us that due to the architectural differences in our computer software or hardware, we cannot be sure that we always get the same return value with the same seed when running this code on different operating systems, such as Linux versus macOS versus Windows. Next, the help page tells us if the result is a vector 2, vector, or vector 4, each component will be a different random number, which just tells us that if we use rand to generate a random vector of any type, it will have different random numbers in its x, y, and z components. And to demonstrate, we have two pieces of code here, which show you how to generate on the one hand a vector containing different component values for x, y, and z, and on the other hand generating a vector which has identical component values for x, y, and z. Finally, we have this neat box here that tells us which other functions might be of interest for us when we're interested in generating randomness, for example. And the structure of this help page stays the same across all functions. More elaborate functions, of course, have more elaborate help pages, but in general, this structure stays the same. So you have the function's name, a short description what the function does, all possibilities of how you could call those functions, specifying the return type and the argument type, then a description what the function does, and maybe some examples. So to sum up, what we have seen on the help page is that we can use rand to generate a pseudo-random number, and we can use it to generate either a float or a vector with either 2, 3, or 4 components.